Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have the function y equals x over natural log of x. We have to analyze this function and sketch its graph. We also have to label if there are any relative extrema, inflection point, or any asymptotes to the graph of this function. Now, understand that before you sketch the graph of any function, you should always try to gather as much information as you can about the function itself. Now, before we go into finding all this different information, just look at the expression of the function first and see if you can get some idea about what the graph will be like. Now, this function has a denominator, and whenever that happens, we know that there is a possibility that the denominator can be 0 or undefined. So, will that be the case for this function? Notice that the denominator is natural log of x. Now, what do we know about that function? Recall that natural log is not defined for x equals 0 or for negative x values. So, that tells you right away that if you plug in x equals 0 or any negative value, there won't be any value to the function. So, we know right away that the graph of this function will be drawn to the right side of y-axis only. So, this function will be defined only for x strictly greater than 0. That we know for sure. And then we have to figure out more information so that we can draw a nice sketch. All right. So, let's continue and see what we can tell about the extrema and inflection point first. Now, you know that we need to figure out derivatives of the function to find extrema and inflection point. So, let's start by computing the first derivative of this function, which is d dx of the function is x over natural log of x. Since this is a quotient, we will need to apply quotient rule. So, recall in quotient rule, we square the denominator. So, in the denominator, you have natural log square. Then, in the numerator, you keep the natural log of x fixed and take the derivative of the numerator, which is x. Then you have negative sign, and then you switch the role of these two. So, you keep x fixed and take the derivative of the denominator, which is natural log of x. All right, let's compute each of these derivatives now. First, you have d dx of x, you know that's just 1. And then d dx of ln of x is just 1 over x. Okay, can you simplify? So, here you just have natural log of x, and x times 1 over x cancels to give you just 1. Denominator is ln of x square. So, that is the simplified form of the first derivative. Now, let's compute the second derivative. Recall that second derivative is the derivative of the first derivative, which is right here. So, ln of x minus 1 over ln x square. Quotient rule again, because it's a quotient. So, you have ln x square and then square that. Okay. Now, take the denominator function, fix it, keep it fixed, and take the derivative of the numerator, ln of x minus 1. Then negative sign, remember, and then switch the role of these two. So, keep ln x minus 1 as it is and take the derivative of the denominator, ln of x square. All right. So, that's the setup, and now we evaluate each of these derivatives and then simplify. So, let's see. For the first expression, we have ln of x square, and then take the derivative. Now, what is the ddx of ln of x? Just 1 over x. And ddx of 1, you know, is a constant, so derivative is just 0. For the second derivative, now this one is of the form a function square. So you have to apply chain rule, first power rule, and then you take the derivative of the inside function. So power rule will tell you it's just 2 times natural log of x, and then because of chain rule, you take the derivative of the inner function as well, which is natural log of x, and the derivative is 1 over x. Now the denominator, you can simplify this by using the property of quotient, that something square and then square again is nothing but to the power 4, because you multiply the two 2's. All right. Now let's see if we can simplify this expression. So the first one, you have 1 over x, natural log of x square. For the second, okay, so the negative sign will distribute. So first you will have a negative natural log times this entire thing. So 2, 1 over x, and ln x square. Okay. Then for the second expression, you have negative and negative will make it a positive, and 1 times this entire thing. So 2, 1 over x, natural log of x. And denominator, you have natural log of x to the power 4. All right. Notice that the first 2 terms are similar. This is 1 minus 2, so it will be a negative natural log of x square over x, and then a plus 2 natural log of x over x. And the denominator is natural log of x to the power 4. And finally, notice that in the numerator, you can have a common factor of natural log of x, which can cancel with one of the ln in the denominator. So you will have ln of x cubed in the denominator, and one of them will cancel out. So in the top, you will have 1 ln x over x plus 2 over x, because this ln x will cancel and one of the natural log from the square will cancel. So we can keep this expression this way, and that is our second derivative. And now we will use these 2 derivatives, first on the second, to compute if there are any extrema and inflection point to the graph of this function, and we'll do it in the second video.